Okay, so we are back with just a stellar video about how to place your bridge rail. We have several templates. You're going to select place the barrier. And right now, the best we've come up with so far is that you have to make a left and a right template. The rail is extruded, so an F shape is basically what you are stuck with unless you want to do a filled corral rail or a filled corral rail with curb. So this is what I'm going to be placing right now, and essentially what I've done for the 42-inch, obviously you're typically not going to have a 42-inch placed from EWS to EWS. However, there are curved bridge applications or whatnot that you could. This has a variable constraint on the height of this top section. It lets you define it just as you do on the deck template, defining variable constraints from station to station. So I'm going to select my left bridge rail, and then I just need to select my candidate. So that's my bridge deck, and this is why I was saying that on the abutments, if you end them at the front face of the abutment and conform your back wall up to the top of deck, you're going to come up short on your bridge rail, which wouldn't, it's not stellar. So placing your deck from EWS to EWS or extending its length to do that is preferred anyway by us. So selecting the candidate, reset, and data point. So this comes up with my candidate working point. And I should have pointed that out in the template, but I will at the next, when I select the next rail template. I'm going to select a guideline from a list. The templates were at least set up for rotating. They were drawn clockwise. Start, end. We're placing the left bridge rail. I'll point out that there's a chamfer. Since it was placed clockwise, this is the start, the P17 corner start. And these templates were modified. So I'm going to go with my P17 corner end, which would be this point up here, as to where my rail is going to be tied to. Hit OK and hit OK. Okay, so it's taken and placed my bridge rail there. The only real way to see if we applied the correct template point is if that chamfer comes down and meets just perfect, because the working point for the bridge rail is right there at the bottom of that chamfer. And it needs to connect with the top point of the chamfer on the bridge deck. You can see that this isn't quite correct. It looks like it's either not being applied. What it actually is there's a gap between bottom of rail, top of deck out here, because obviously there's a cross slope. This was defined, the rail template was defined as 32 inches tall up to top of rail, as defined from this bottom point right here at the face of the curb. So just need to select it, go into variable constraints. So shoulder left one, I want to make that active. Make this, if you remember, the cross slope of my left shoulder was 3%. I need to make sure that it's applying it correctly. So negative 3% is going to tie that right down to the bridge deck. It actually adjusts every point in the geometry to make sure that this right now is 42 inches. Go to place barrier, and look at my right final. See right down here, This is my working point, T0 working point. So that's why that needs to be applied to the very top corner of the chamfer bridge deck. So I've got that. I'm selecting that. It wants me to select the candidate, reset, data point, select my guideline. Again, with it being drawn clockwise, this is 0.2. I used corner end last time on 0.17. On 0.2, I want to use corner start. Okay, hit OK. So again, it's digging into my bridge deck because it's just drawn perfectly flat. So I need to select the bridge rail, go to variable constraint, shoulder right, 47. Say OK. Oop, hit her the wrong way. Okay, brings this up right at the bridge deck, and it adjusts every other point based on where that point is, where we adjusted it to. The cool thing about this, and it's a blessing and a curse, the other variable constraint is the transition. So I'm going to define from support line 1. So right now it's at 10 inches. The interval length is 40 as I entered it down here. I have tried making this 0 inches, but due to the fact that I put a chamfer on the geometry, you'll see that this doesn't work so well. I want another point, so relative location can be 70 out. This from 40 feet to 70 feet, I'm going to transition it from 0 to 10 inches, 0.833. So for the first 40 feet, it's, and then from 70 feet on, add another section, 70. I've just lost connection to KDOT computer, so I will continue this video in a couple minutes.